Welcome in. There's some chairs up here, one over there. Grab whichever one you like. Okay, we're just gonna get started. Thank you guys so much for coming. My name is Arby, and welcome to UC Berkeley STAR, Space Technologies and Rocketry. This is our third info session of the week. Don't worry if you missed the other ones. They all cover the exact same material. So yeah, thank you so much for coming and being here. So I wanted to quickly start off with showing you guys one of our launch videos. So this was a really, really important rocket for us, Bear Force One. I'm just going to hit play and talk you guys through the launch. Okay. So this rocket was called Bear Force One. It was our competition rocket, and it launched in 2021 in the middle of the Mojave Desert. Sorry, this projector is not working right now. But as you can see at the bottom, we have... Let me make it a little quieter. But so this was... Thank you for that, Cassidy. So yeah, this launch was really, really important to us. This was the first time that we competed at IREC, which is the Intercollegiate Rocket Engineering Competition, right? So this was really, really important for us. We got 17th in the world against quite a lot of teams. So that was a really great feat for us. And yeah, we are a competition rocketry team, but I'll talk more about the other facets of our team later as well. But if you later kind of want to check out a little bit more about this competition rocket, I encourage you to check out the IREC posters back there. We'll have a poster walk around later as well. So yeah. Oh, go for it. Yeah, go for it. 17th and what? So it's judged on a lot of different things. So if you want to later check out that poster back there, the whole point of it was to reach a certain altitude, no higher, no less. We're also graded on our payloads. We're graded on the structure of our rocket, how much we manufacture ourselves. So STAR is a very independent team in the sense that we build most of our stuff all by ourselves from the beginning. So a lot of our avionics are custom made. Our whole flight structure is custom made as well. But yeah, I encourage you to check out the posters. And Kalu, where are you? Over there. She's leading our current IREC competition project team as well. So all questions can go to her as well. The next video that I'm going to show you guys is a liquid engine hot fire. So Liam over there and Dylan help lead our liquid engine program right now. But this was our first liquid engine that we ever kind of made. And this is it was called Ellie, and this is its hot fire. I'm gonna click play. So it took us a couple tries to get this right, but this engine runs on gaseous oxygen and ethanol. And we kind of drove all the way out into the middle of the desert again, and we assembled it. It took us 2 tries, or 2 trips to the desert to get it done right. But that's like all part of the engineering process, right? We locate flaws and we redesign based on that. So over here, you'll see our first static fire. This was unsuccessful, but as you see, we see our igniter burn. But then basically what happened is that our oxygen didn't go off. So it was just this liquid ethanol dumping out, right? So that's obviously not exactly what we want as a team. Also, if you guys want to see a little more, you can walk over. Oh wait, that projection's working. But yeah. Let's wait for our second static test. This was our first successful static test, which was 3 seconds long. So our igniter's going off. And then, yeah, the flame is a little pale to see, but you can definitely hear it. I put the volume on low because it's very, very loud. And this was our third static test. I think it went for about 6 seconds almost, but
this is system that things like valves, flow control, elements, detectors, cooling methods, and then eventually we'll be using this to swap parts onto our flight vehicle as we get more and more into an optimization. This year we're building a liquid flight vehicle to optimize from 10,000 feet. So it comes with a whole new set of challenges, cryogenic oxygen, obviously a flight package, which is
crazy.
6-inch airframe. We're going for about 55 to 65 pounds, converging on like 60 under. So
yeah, so basically what Ellie is like a test stand for us to develop future liquid engines. Does anybody know what the difference between a solid engine and a liquid engine is? So the rocket you saw before was running on a solid motor, right? But this one's a liquid engine. So does anyone know the difference? Some differences. Yeah. Anything.
And then one can throttle a liquid engine and shut it off or abort if you need to.
Yeah, so solid motors, once you fire them, you can't stop. So, you know, it's one go or nothing with them. But yeah. Does anyone else want to name another difference between solid motors and liquid engines?
It's all good, you'll learn.
Yeah, it's all good. Don't worry. You guys don't need to know anything what I'm saying right now. It's totally okay if you're seeing these videos and you have no idea what's going on. We teach you everything you need to know from the beginning. We accept all majors, all backgrounds, super inclusive. But to name a couple differences, a couple other differences between solids and liquids. Dylan, would you like to help us out here?
You need a full feed system for liquid engines. Solid motors all contained in one grain, while you need tanks, pumps, well, not pumps, but you need a whole like instrumentation feed system to actually get liquid for. Plus a lot of sequencing, which is much more difficult for this lighting engine and letting it go.
Yeah, exactly. Liquid engines are an extremely complex propulsion system, while solid motors are much easier on that front. But yeah, liquid engines are a lot more powerful and can get it's a really big step forward for our team. So yeah, it's a huge part of kind of what we do. Oops, this is playing again. Okay, so as you can see over here, there are like a bunch of little rockets flying. That one's actually mine. But I would like to invite both Peyton and Nathan to come up here and talk about what this is all about.
So these 12 rockets were launched as part of the L1 program, which is level 1 program. Do you understand what level 1 means?
Yeah, so out in the world of rocketry, there are certain certifications and you can personally get to build your own rockets. L1 being the first one, also goes up to L2 and L3. Once you get these licenses, which you get by building your own rocket and launching it all yourself, it lets you buy things like rocket parts, motors, explosives, whatever you're looking to do to build your own rockets in the future. And as you get better and learn more and more about rocketry, you start from building an L1 like this, something bigger like an L2, and then eventually you get up to an L3 and launching a rocket that size in the corner here, all by yourself. It's a very, very cool program we do. We're going to teach you everything you need to know. We'll give you all the components, all the parts, so you can build your own rocket from scratch. We'll hold your hand while you do it, make sure everything is right and good to go. Teach you everything you need to know, and we'll ship you out to the desert, launch a rocket, and you'll have your own
We're not
L1
gonna ship you
certification.
out, we'll be-
We're coming with you, don't worry.
But yeah, me and Nathan launched ours last year. They went about 1,200 feet in the air. It was pretty cool. We got a card to go in our wallets if they're level 1 certified. Yeah, and then we fund it, the whole thing. So it's just like for you to get your certification, and also it helps the club too in the long run. We have more certifications on the team. But yeah, and then you get to paint it in whatever color you want, which is fun. Mine was red and gold, like Lightning McQueen.
Yeah, Andrew, I know it's something we recommend all of our members doing. It's a really, really cool project. You do everything you need to know about rocketry from the ground up. And like we said, once you have them, it's useful for us because we can use these certifications to train new members. So you get to be in that sort of teaching cycle. It's a very, very cool process. Plus, you get to have a really cool rocket in your room, and that looks good on a resume or an interview. You can show off this giant rocket that you built and launch yourself. So it's a really, really cool project for everybody. We love it.
Awesome. Thank you, Peyton and Nathan. So yeah, the L1 program is one of many program certifications that STAR kind of offers training in and leads you through the whole process. So the L1 program is basically where you build your own rocket and you get certified by the National Rocketry Association, which is very, very cool as well. So just kind of to give you guys a brief overview and agenda of what today's going to be about, we're going to go over who we are as a team. So like, what is STAR? What do we do? And the next thing that we're going to mainly go over is projects. So we do a variety of projects. You might see like the posters scattered around the room and like all the rockets that you see or gadgets everywhere. And the next thing that we'll go over is how you guys are going to learn. So obviously we don't expect anybody to like know about rockets. It's not like a thing that people generally do. So we teach you everything you need to know from the beginning, and we fold your hand through this process, and we have a really strong mentorship program that and we really, really just value education as like a huge part of our team. And the last thing we're going to go over is life in the team and what that's all about. So without further ado, who are we? So we have 4 main pillars: competition, education, research, and outreach. So the first main pillar that we do is competition. So this is what kind of makes us different from other rocketry kind of organizations or clubs that you might see. And we are UC Berkeley's competitive high power rocketry team. And our competition rocket that we fly every single year is IREF, that Tolu leads, and I briefly mentioned before. And some of the goals that we've met in the past is we won first place at FAR 1030. So that was a competition in the Mojave Desert. We were first place. Yeah, and we won 17th place in the world at IREC. Let's go.
On our first try.
On our first try, that's right. So competition is a huge part of our club, and we design all our rockets with that higher standard in mind, like thinking about how we measure up to different teams and around the world. So the next main pillar we have is research. So in addition to our competition projects, our main competition rocket, we lead a variety of research projects with hopes that one day our research can be integrated onto our competition rockets and we can fly all these other cool things that we work on the side. So our main research projects include our liquid engines that Liam and Dylan kind of talked about before, and our payloads. So we do a lot of really cool payloads. So up over here, you'll see a glider payload. So Kaiten and Nathan kind of lead that initiative, and it's called Dave. It's a deployable aerial vehicle, if I got that right. Yeah, and it's a glider that deploys out of a rocket mid-flight to fly around. And this is an ongoing project. It's extremely cool, something that literally no other team has done before. So we really like to push the boundaries of science and technology on our team as well. The next main pillar that our club kind of focuses on is education. We have a really, really strong education program, and I think that's what really makes STAR special, is that we really, really care about sustainable growth and member investment. So when you come to our team, we don't only care that you become like one of the best project members or you become super smart about rockets. We care about you as a person and how you grow and how you develop inside and outside of the classroom. So what we kind of have is an intro project program. So every single new member on our team is going to be paired into a mentorship group. And in that mentorship group, you'll be paired with a star member that's been on the team for a couple of years, knows the ropes, knows what they're doing, and they're going to teach you everything you need to know in 5 to 6 weeks. Right, so you're gonna kind of go through that inter-project process. It's gonna be a little difficult, but we will be there for whatever you need. We have office hours, we have lots of resources, we have a website, we have textbooks, worksheets, things like that. So like we have a whole program to really help you through that process because we don't expect that you come in with a lot of rocketry knowledge, but if you do, that's awesome as well. And another main thing that we have is we have a lot of workshops throughout the year. So we want our members to continuously grow. We have workshops on different softwares, and we're working with a lot of different companies right now to give you guys that full experience and to give you guys that industry certifications as well. Tuli, do you want to add something?
Yeah, I just want to say please intimidated or feel projects. Teams here tend to focus on application processes. It's not a process to weed you guys out. It's a process to help you guys transition in knowledge and get you guys ready to work for the projects that you will be assigned to after learning about your specialty. So it's all about learning, not about trying to pick you guys out.
Yeah, we accept every single member onto our team. We are extremely inclusive on that front, and we provide a lot of resources for you guys to succeed as a member of our team as well. So yeah, and other kind of education related initiatives we have is we really have a strong alumni network, and we do things like resume reviews and other kinds of programs to help you guys succeed both inside and outside of STAR. And our last main pillar that our lovely Rachel and Anjana over there lead is outreach. So we are very, very passionate about our impact on our local community. And we do a lot of community volunteering. We've impacted over 5,000 local Bay Area students. And we also run a scholarship program with the nonprofit Next Gen Girls. And this hands out, you'll see the poster back there. But we're basically trying to hand out scholarships to low-income women of color who want to pursue 4-year STEM degrees. So yeah, outreach is a huge part of our club as well. We kind of have it all, something for everyone. So yeah, we hope you guys join. So kind of moving into the specifics of our club structure, how it works. So it's a little complicated, so don't worry if you guys are getting lost, just raise your hand, ask a question. We're super open to questions and feedback. So as a new member on our team, what you guys are gonna do is you're gonna join one of these specialties up here. So we have airframe that Tulu leads, avionics that Cedric leads. I don't think Cedric is here right now. We have payload that Peyton leads, propulsion that Liam leads, recovery that Cassidy leads. Where's Cassidy? Oh yeah, okay. And ops that Rockland leads, who's not here right now. We also have business, media, and outreach. Outreach is led by Rachel and Anjana. Our business and media leads are not here. But so we have a variety of technical specialties and non-technical specialties. So what this means is you can choose an area of rocketry to focus on. So if you guys don't know what these words are, airframe, Tulu, do you want to give us a little explanation of what airframe is?
Sure. So airframe is basically the structural component of the rocket, so the rocket itself. And it's everything about how we house the things inside the rocket. So what goes inside, where it goes, where things are, what force loads, pressure differences there should be. And we do a lot of manufacturing, like Arby said at the beginning. We tend to create everything that we can ourselves. We just buy materials and get building. So that's a huge part of airframe as well.
Yeah, airframe has a lot of really hands-on work. So if you're into that,
CADing,
yeah.
those of you who like CADing stuff like that.
Yeah, lots of design and CAD work. Thank you, Tulu. So the next kind of technical specialty that we have is avionics. So avionics focuses on the computer systems, the hardware, the software that goes behind our rocket. If you guys look all the way over there, we have CAS, our Common Avionics Stack. So this was a project we've run in years past that focuses on avionics component. It's like a modular system. You can go check that poster out later. But avionics is a really crucial part because everything that we, a lot of the things that we do are like pre-timed and stuff or like remotely controlled. So we need to have all the buttons, all the things working, or shit will explode. The next tab is payload. Brief overview of what payload is.
Sure. So payload, we built all the experiments that go inside of our rockets. It's what makes rockets worth launching. So our two main projects this year are Dave and the IREC payload. So Dave is the glider, like Arby talked about. So we'd be working on like aerodynamics. We're trying to redesign Dave for the second prototype. So it's also a lot of CAD work. There's also for IREC, literally we're just trying to think of cool ideas that we can make happen. So if you have an idea, please let me know. We've heard things from like a waffle maker to something that measures air pollution. So we literally will do anything that's cool. It's a large variety of work. So like you're never stuck in one thing over and over.
Yeah, payload is a really special part of the team that a lot of like different majors can be applied to in particular. The next main specialty that we have is propulsion. Liam, do you want to give us an overview of what propulsion is?
Yeah, propulsion, we propel the vehicle. We work really closely with basically every other subsystem to give them the control optimization to guide a rocket to as close as we can to 10,000 feet. And work a lot with like fluids and physics modeling, instrumentation and control. Lots of sensor fusion, things like that. A lot of thermal stuff, vibration and frequencies, something we're working hard on this year. So yeah, a lot of cool stuff.
Yeah, propulsion is the boom that makes the rocket go up. So yeah, good stuff. The next main technical component of our team is recovery. Cassidy, do you want to kind of talk about recovery?
Sure. So our goal in STAR is to be able to reuse everything end up into the air, and that's done through our recovery system. So this involves designing avionics space, which figure our parachute deployment, and we also worked on space mechanisms for a big rocket. We do a lot of CAD work, a lot of machine shop, and like hands-on kind of making things.
Thank you, Cassidy. Yeah, so the parachutes basically make our rockets and not missiles. And operations. So operations runs the logistics on the team and the safety of the stuff that we work with. We work with a lot of things that could be considered dangerous, I guess. So ops is there to kind of keep us all in check. In our non-technical specialties, we have business. So business works with a lot of our amazing sponsors to get us those deals and packages that we need, and it basically funds these thousands of dollar projects. So a lot of the sponsors that we worked in the past include Boeing, Blue Origin, really amazing big names that really just help us out. We have a lot of like connections with internships, alumni networks, things like that. So business oversees a lot of that work. Media does a lot of the amazing videos that you saw, that you just saw. We love them so much. They also make our merch and a lot of other cool fun stuff like running our social media accounts and things like that. And our last main pillar is outreach. Rachel, do you want to give us a little rundown of what outreach is and what it's all about?
As I said earlier, also have a scholarship program.
Yeah, we're really hoping to make a long-term impact in our community because a lot of us are engineers, and it's great that we're doing all this amazing work. But what is also important is that we spread that work and education and accessibility to the next generation so we can spread our passion for rocketry. So before I bore you guys, we're going to have a little bit more of an interactive next portion. So what's going to happen is you guys are going to be able to explore our current projects. So you won't see a poster for a minimum diameter rocket, but we'll talk about it a little bit later. But our current projects that we're running this year include the 2023 competition IREC rocket. So that's the one to leave. We have our two-stage stage separation rocket that Cassidy helps kind of run. We have our liquid engine project that's led by Liam and Dylan. We have Dave, our deployable glider project, which you see over here. That's led by Caitlin and Nathan. Thanks, Jonah. Jonah helps lead our stage set project, by the way. Yeah, and we also have our new project that we're starting this year called the minimum diameter rocket that Anjana and Megan is unfortunately not here, but both of them lead that. So without further ado, super quickly, could we also move the posters out more throughout the room because they seem a little crowded over there. Especially like Cass, if we could move Cass and Dave, if Dave could be up here or in that corner. Okay, so what's gonna happen is we're gonna kind of have a poster walk around session, right? So all of our like leads and like people that work on our projects are gonna be standing by the projects that they work on. And they're gonna also have these like project posters that we've made as well. So we encourage you guys to get up, walk around, talk to people, ask what their experience was about. And yeah, explore all the different projects so you guys can get a better idea of what you want to work on. We'll give you guys about 25 minutes. I will answer general questions. Yeah, go for it. Yeah, so they're already gonna be uploaded this weekend. I'm doing to fill out the agenda. Yeah. Okay, thank you guys so much for kind of having a good time walking around. So, big question that a lot of people might be wondering about, what specialty should I join, right? So you guys just saw projects, however, you're trained in a specialty. So that's the thing that you are the most confident in. Those are the technical skills that you gained, right? So let's say you want to work with Toulouse on airframe, right? You're really interested in the structure of the rocket, right? So that's gonna give you the option to join IROC or competition rocket, stage set, our stage separation rocket, Dave, which is our glider payload, which is flying on another rocket called Bear Force One. And Mindy, which is a project we're going to briefly talk about later, and LE2, our flyable liquid engine. So there are a lot of options for airframe, but as you see, recovery is also on a lot of them as well. Avionics is on a lot of them as well, but propulsion is really on LE2. So we'll talk about this a little bit more at our first GM, but it's just kind of some things to start thinking about, right? So I want to invite Anjana up here to talk about minimum diameter. So Mindy is our new rocket that we're building this semester. But yeah, let's give it up for Anjana. Mindy's gonna be
minimum diameter rocket is based like in most of the rockets that you see, like the posters that you saw, there's like a motor mount tube which mounts into the actual body tube. So there's like two concentric cylinder tubes.
It's okay if you don't know what this means yet. We'll explain it all later.
Yes. But with Mindy, motor, like there is no, the motor mount tube is the body tube. There's no like two separate tubes. If you don't get it, like we will accept it. It's not very easy, I promise. And so this is a proof of concept for Stage Step 2, which is that poster. We'll have an idea of what that is, and all the future star rockets. The design challenges, particularly the Mindy, are keeping the motor in the motor mount tube, which is also body tube, and also mounting the fins because there's no like entry into which is normally how we mount fins. So yeah, if you want a 1 semester manufacturing intense experience.
Thank you, Anjana, for sharing. Okay, so kind of just putting everything together that we kind of talked about today. How does this all work? So the first general meeting, now that you guys are here on our info session, our first general meeting that you guys are invited to come to is on September 8th. This is a Thursday from 8 to 9:30 p.m. We'll also be sending an email out about this. So don't worry if you don't want to write it down right now. So then what's going to happen is as new members, you're kind of going to be on this intro project track, right? So this intro project is where you're paired with your mentorship group and you're basically taught everything you need to know about rocket science to kind of contribute and be an impactful member on our team. Right, so this is going to last a couple weeks long, and it's going to end with a little new members retreat, and that's going to be on October 27th. 2022, and obviously, and then you're going to be integrated onto our team as a full member of our team, and join a project. One of the projects that you kind of saw we talked about today. So that's kind of the timeline of how you guys are going to be full members of our team. So it's kind of like a 1 semester long process, I would say. And just to kind of end off, I wanted to talk a little bit about life in STAR. We definitely have a work hard, play hard mindset, and our first team-wide social is going to be on September 24th. We also have like smaller socials between like project groups or like specialty groups and things like that. And yeah, we really prioritize having like a good social life to complement our really good work life as well. So yeah, and we also are planning our first whole team retreat in December where we're all going to go camping together. So that's going to be very, very fun. And yeah, lastly, I wanted to end off on basically why join us, right? So STAR is obviously an engineering team. However, in general, we have a lot of like practical skill set development, right? So you go to class every day, you learn all these formulas, equations, maybe you're not in STEM, maybe you learn about a lot of other different useful things. But connecting that knowledge that you learn in class to real life industry work is a pretty big step. And it's things that a lot of graduates kind of struggle with as well. So STAR really helps kind of connect that, I would say. And it also gives you experience on working on a large engineering team, right? So again, like in group projects and stuff, you're working with maybe 2 or 3 people, right? But STAR really helps you kind of visualize what it's like to work on a large team, large scale projects, how much communication is actually there between each and every like one of those tiny components, right? We also have projects of all scales, like a lot of major industry companies do. And we have a lot of our industry partners and companies that our alumni work with that are up here. And we have a really, really strong relationship with them. And our reputation definitely precedes us. Like I go into job interviews and I'm like, hey, I'm a member of UC Berkeley STAR. And they're like, yeah, we know who STAR is because we have a lot of amazing hardworking students that have come out of our club and done very, very well and become extremely successful engineers at a lot of these places that you see up here and a lot of the big names, I guess. So yeah, how do you join, right? So right up here is our QR code. So that's going to be our Infosession attendance form. We also have QR codes up there. I think we might have 1 or 2 more right somewhere. But yeah, they're kind of posted around the room. Oh yeah, up here.
There's ones on the wall, the back wall by the exit door for anybody who's by that wall.
Yeah. So we ask that you guys fill this out. So we're gonna just basically send out an email in the next couple days to kind of confirm everything, give you guys all the details. We'll also be sending out the slides and the recording if you want to reference that. Please email us with any questions, comments, concerns, talk to us. We would love to talk to you as well. But yeah, that's about it. Thank you guys so much for coming and welcome to STAR.
Oh, you guys don't want to leave?
That's right. We'll tell you more. Yeah, exactly. Oh, also, sorry, super quick. I got a quick question about this before. We have 0 membership fees. We ask you guys to never pay for anything. We pay for everything because we really prioritize financial inclusivity on top of everything. And we also accept every single member, regardless of major, regardless of background. We just ask that you guys show up with a good attitude and ready to work. And yeah, STAR will take care of the rest. But yeah, thank you guys so much for coming.